Hey everyone. So, yeah, so today I went over, or I participated in the Codeforces Educational Round. I was only able to solve A, B, C, D, and E. Um, so I'll be going over the solutions to those, and then I'll discuss G a bit because I had some thoughts on it, and maybe I'll try to finish solving it. We'll see. Um, but yeah, I'll get started in a couple minutes. Just waiting for a couple more people to tune in. Yeah, some people are saying couldn't understand B. B was really hard. Link is not updated in CF. What does that mean? Like this, I guess. Okay. Stream will start soon. Hmm. Stream is fin. Okay, that's annoying. Hmm. Wait, am I? I'm live, right? Okay. Um. Okay. Cool. Yes. Someone's responding, so I must be live. Okay. Perfect. Cool. So, yeah. What did people think of the contest? Seems like there's a huge drop off from E to the problems after that, which I don't know is why I only got up to E. But cool. I guess I can get started. Seems like people have trickled in. Oh, and I guess before I get started, just I wanted to point out that I upload all my stuff to YouTube later, so you can check it out there. I also did a screencast of this contest that I might upload if I think it's useful enough, but it's a bit long. And I have a Discord, so feel free to join the Discord so you can stay up to date on my future streams or, just hang out with my other viewers. um, cool. So let's get started with A. Um, all right, and as always, someone's asking, "Am I Indian?" My ancestry is from India, and I'm from the U.S. But this is a stream about competitive programming, not like my national origin. So let's see what other people are saying in the chat. E was really messy. Someone said A through D was very easy. I wish. I thought B was really hard. um, when is the AMA coming? That's funny. Um, did not get C. Okay, cool. So let's get started with A. So basically, what we're saying here is you have a bunch of heroes. We'll go through the example. We'll just go through the last example where you have heroes of these strengths. And it's saying that when two heroes of equal levels fight, nobody wins the fight. When two heroes of different levels fight, the stronger one wins. Oh, wow. And his level increases by 1. Honestly, I never even saw that. Um, maybe I should have read that, but it didn't really matter. Cool. Gotta hydrate. So basically what we're saying here is that there's only one fight each minute, and it could be the same fight over and over. So we can really simplify this problem, right? The winner of the tournament is the first hero that wins in at least some big number of fights. But what you can do is whatever the last fight is, you can just repeat that fight over and over. And the same person will win every single time, right? Since the winner's level is increasing. So what you do is this basically turns into you have two people fight, and then whoever wins that fight wins the whole tournament, and calculate the number of possible winners. So we just have to see if each person is capable of winning any fight. So this person can't win any fights. This person can play against one and win, and same with the other people. So basically what we have here is you can win the whole tournament if there exists somebody less than you. So, I mean, we can look at my code for this. So basically what I did is I found the weakest person, and anybody whose strength is not equal to the weakest person is possible to win the whole tournament. So because they can win the whole tournament, you increment the answer by 1. This is basically like, you could do this a bunch of ways, right? The implementation doesn't really matter. But basically what we're doing is we're counting up all the people except people who are tied for the weakest. And that's that. Let's see. D was hard. A and B. Yeah, B. Okay, so B took me like 20 minutes or something. Like, I guess if we look at my submissions, right, A took me a couple minutes. B took me like almost half an hour and 2 wrong answers. And then the next 2 problems took me like, 5 or 10 minutes each or something. It's kind of funny. But cool. And then someone says your accent is quite like Slash. Actually, who is Slash? Is that a gamer or something? Okay, cool. So let's go on to B. Definitely the hardest problem from. Okay. Yeah, I guess I was just thinking it sounds like a gamer tag from like a famous Twitch streamer or something. All right, somebody keeps saying camera. What is that? Let me know if there's something I'm missing. Oh yeah, and if you're not following already, definitely be sure to follow. Subscribe if you want to as well. So let's see. Thanks for the follows. Okay, so for a B, it's kind of I don't know. I found this problem very difficult, but I probably could think about it more clearly than I did. So let's see if we can work through that here. So for B, we basically have a bunch of spots, right? And initially, cat B is here and cat A is here. And then over time, they move in opposite directions, like this. And then here we can see if n is even, then B will just nicely skip over A. And the answer is just like k mod n or something, right? Like k minus 1 mod n plus 1 because of the zero indexing versus 1 indexing. So n is even is like the easy case. So now let's go to n is odd. So let's draw an example. Let's say we have 7 spots, right? So we have B and A. Oh, someone's saying, what camera are you using? I'm using the Razer Kiyo. I got it a while ago. It seems fine. Pretty HD. The only weird thing is sometimes the autofocus like kind of triggers automatically. Is this stream going to be saved? Yeah, so you can see my streams on my Twitch, but they're only for a couple weeks, and then you can check out my YouTube. So I'll upload this in a day or 2 on my YouTube. Okay, so let's see what happens here, right? We have something like this, and then A goes to the middle spot first, and then B skips over it. And then if you look at what happens next, A always moves to the left, right? Like A is unaffected by anything because it's more senior on the hierarchy. So, and B continues to move to the right until, so you'll notice that when B goes back to spot 1, that's actually the same time that A would be in spot 1. So, wait, hold on. That's not right, actually. I think I miscounted. Oh, yeah, okay. So B will be at the end when A is in... Oh, I should have drawn like a grid or something for this one. Um, you can see why I found this problem so difficult. Oh, I see. Right. So B goes kind of one more than A after it crosses this halfway point at each time step. So what happens is B is at the last spot when A is at almost the first spot. And then they'll collide again. A will go to the first spot. So I think I drew too many things here, but A will go to the first spot, and then B will also try to go to the first spot. Wait, let me look at my piece of paper. This is super weird. I moved B by one extra. It's fine, we get it. I wish I got it. Oh, Neil, thanks for the subscription. Yeah, what the heck? What did I do for this? Okay, so let me erase the stuff and kind of skip ahead, right? So at some point you have a bunch of blank, you have a blank A, and then you have a bunch of dots, and then you have B at the very end. And then A will go to the beginning, and B will also try to go to the beginning. So B will end up at the second spot. Ah, right, okay. So this is what happened. Do you want to review C and D first? Yeah, C and D were much easier. So if you stick around until I finish B, I'll breeze through C and D. Okay, so basically what happens here is we can kind of see that B will collide with A on like some periodic thing, like twice per cycle through the whole thing. And so B gets to move like an extra spot whenever it collides with A. So my code is kind of messy for this also, I'm sure. I guess it's not too bad. So basically what we do here is we see that so this is how I approached it, and I'm definitely going to ask people in the chat to, you know, let me know if you had a cleaner way to think about it. But basically, like, if you kind of look at the pattern, like, let's say n equals 7, then after first 3 steps, right, which is n minus 1 over 2, then B collides with A, and it gets, like, an extra 1 step. And then after the next n minus 1 over 2 steps, it collides with A again. So it collides with A every n minus 1 over 2 steps. Oh, someone said I can't see your code. Oh, it was behind something. Oh, okay, sorry. I also have this... Okay, that shouldn't have been there. Sorry, I had my stream set up as if I were gonna stream like a Codeforces duel. Okay, so let's see. Yeah, that should be readable. So what happens is every n minus 1 over 2 steps, A and B collide, and B gets like kind of 1 extra boost. So effectively every n minus 1 over 2 steps, B gets to move by n plus 1 over 2. So the way that I thought about this is the number of boosts that, or sorry, I guess the number of like full cycles that B goes through is k divided by n minus 1 over 2, and then you multiply that by n plus 1 over 2 to get the total distance that B actually moves. And then you also have to add k mod n minus 1 over 2 just to say how many extra steps you go after the last collision. And then you want to take that whole thing mod n. So in the end, I think that's a pretty simple way to think about it, but it took me a while to get to, and I definitely had like some errors. Like, I forgot to mod this whole thing by n. I just modded the last thing by n, and I think I might have gotten overflow issues and stuff. But that's basically the way that I thought about it. Okay, let's see. Checking on the chat. Someone said, "What's a duel?" Okay, so for the duel thing, just in case anyone's interested, if you join my Discord, there's a channel there where you can duel other people on racing for solving Codeforces problems. So that's pretty. Oh, exclamation mark Discord. You can find the Discord. And then someone said share the link so I can watch from the start. Okay, so if you do rewind, you can see how to go back. Can you explain n minus 1 and n plus 1 again? Yeah, let me clarify this a little bit more. So this is kind of just with the example of n equals 7. So n minus 1 over 2 equals 3, and n plus 1 over 2 equals 4. So what happens is when b moves, every 3 steps, b gets a 1 like bonus step because it collided with a and got to go 1 further. So what this means is the number of bonus steps is equal to k divided by n minus 1 over 2. This is the number of bonus steps. So, oh, I guess a nicer way to do it might have been to just say, okay, I'll explain it the way that I coded it, and then I'll try to change my code to make it slightly cleaner. So the number of bonus steps you get is k over n minus 1 over 2, and for each full cycle with a bonus step, you actually move this much. And then after each full cycle, or after the last full cycle, you had a bit of leftover, which is k mod n minus 1 over 2. So that's the total amount of steps that b was able to move. And then once you find the total number of distance, sorry, not steps, the total distance that b moved, you take that modulo n. Why not n over 2 plus 1? So n is odd, so n plus 1 over 2 is the same as taking n over 2, flooring it, and adding 1. Who is Bihan? I'm not actually familiar. Let me know in the chat, please. But yeah, this is only for n is odd. For n equals even, this problem is very simple because a and b never collide. So I think the maybe slightly cleaner implementation is the number of cycles is how much extra you get. So I think maybe you can just do this. And maybe that will be right. So like, yeah, so each full cycle you move 1 extra square. Let's see if that passes the samples. Okay, cool. So that does pass the samples. We can try submitting it. Okay, so this is a much cleaner way to do it than I originally did. So basically every time you move this far, you get to move 1 extra step. So I think this is like the cleanest way to do this. Okay, great. Now we can move on to the easy problems, C and D. Oh, cool. Is Bihan, that name sounds kind of familiar. Is Bihan a famous competitive programmer? Okay. So here we go. I guess to be completely fair, for C, I didn't prove my solution. I was just pretty sure it was right. But basically what we have here is every team plays every other team, right? So that means every team plays n-1 games. And so you can kind of think about what possible scores each team could have in terms of how many games they win versus tie versus lose. And So the way that I thought about this is, first of all, if n minus 1 is even, then you can just have each person win exactly half, or each team win exactly half their games and lose exactly half their games. So if you do that, right, you have each team win and lose exactly half. So each team will get the same score because each team wins, loses, and ties the same number of games. So this is a pretty easy case. You can this allows you to get 0 ties, which is clearly the minimum possible. So now we have the case where n minus 1 is odd. And for this, what I did is I had each team tie exactly 1 game. And when I did that, then after you do that, you can just have the remaining games split half and half into win and lose. So you end up getting n over 2 ties. Each team wins half, lose half, tie 1. And if each team ties 1, you have n over 2 ties, because you if you have n over 2 games that tie, that means each team had 1 tie. So basically what I did is I implemented this and I thought for a little bit, and it seemed like you probably couldn't do any better, so I submitted it and moved on. But let's see if we can actually prove this kind of more rigorously. Someone in the chat says you can prove this by making a graph of n vertices and directed edges, where an edge direction tells us about the win. That's pretty cool. Okay. So let me think about that formulation. Though let me try to see if I can remember what I was thinking during the contest about this problem. So let's say you have to be concrete, let's say you have 6 teams, right? So team 1 will play against 2, 3, 4, 5, and 6. So I think so if you have fewer than So I guess I was kind of thinking if you have a team that doesn't have any ties, then it either won more than half of its games or lost more than half of its games. And then it's not possible for every other team to tie with that team. Not tie, but every other team to have an equal score to that team. So let's say a team wins more than half of its games. So if you win more than half of your games, then your total score is 3 times the number of wins. And the total score available for each game is only 3. Across the two So the total, so let's say the total points available is n choose 2 times 3, or less if you had ties. So let's say minus 2 times the number of ties, or actually it's minus 1 times the number of ties. So if you have a team that wins more than half its games, and all the teams have the same score, then you have n times w. 3 times n times w is the total number of points that were given out, which is going to be greater than let's see, 3 times n times w would be greater than 3 times n times n minus 1 over 2, right? Because you won more than half your games, which is definitely greater than the total points available. So that doesn't work. And then if you have a team that doesn't tie that has fewer points, I guess that's the part where it gets slightly tricky. Oh, let me see what was written in the chat. Oh, combo thermal. Are you like geothermal from Codeforces? Okay. You like is that because you like combinatorics? Okay, so let's see. So you're saying the number of points has to be evenly divisible by n. Okay, right, because it's the score that each person gets. Oh, I didn't realize geo is like geometry. That's pretty funny. With no ties, okay, yeah. So this is the n choose 2 times 3 minus the number of ties. Ah, okay. This is a pretty nice proof. Okay, yeah. So this is much nicer than this, like, you know, in this case you have an inequality. In the other case, I don't know. Yeah. So let me kind of write what geothermal was explaining. So the total points equals n times let's say x, where x is the score that each team gets. And it's also equal to 3 times n times n minus 1 over 2 minus the number of ties. And so what was pointed out here is that if you look at this mod n, you get 3 times, let's just write it out the long way, minus 3n. Actually, sorry, that's not a good way to write it out. N is even. Okay, so when n is even, n over 2 is an integer. And that's the case we're in, right? Because n minus 1 is odd. So what you end up having is you have n over 2 times n is an integer that's a multiple of n. So we can ignore it. So we end up having 3 times negative 1 times n over 2 minus t. This is all modulo n. And then this is like, if you just, you know, do this out, you get n over 2 minus t modulo n. So we need t to be a multiple of n over 2. Actually, I guess we need t to be congruent to n over 2 mod n. So that shows that, so that's kind of a nice, oh, that was a really nice proof. Thanks for pointing it out. But yeah, this is the proof that this is the optimal construction. And then we can check out the code. My code for this was a bit long because I wanted to make sure I didn't make any mistakes at all. So you can ignore almost all of this. But basically what I did is, as I was going, I also kept track of the scores, and then I printed the scores just to make sure that my construction was actually right. But yeah, so for my construction, what I did is, for each pair, you can consider the first one, and to make it beat half the teams and lose to half the teams in like a consistent way, you can have like team 1 beat like the first half of the teams after it and like lose to the second half. And if you just do that, that turns out to be consistent for all the pairs of teams. And then for tie, you just have to add an extra case for tying. And then this construction works, and it, you know, I computed all the scores just to check they were the same, to prevent any off by 1 errors. So I submitted that. Cool. Yeah, I used to thought educational rounds were supposed to be like mostly data structures or like something like that. I think what happened is like the original educational rounds, and definitely let me know in the chat if other people know this, um, but or if people have corrections. But I think like originally educational rounds were supposed to be like standard problems, but then they were unrated. And then eventually they made them rated, and then when they made them rated, they were like, well, now we can't just ask textbook problems, so we'll ask original problems. And now I don't really understand the difference between educational rounds and regular Div 2s. Like they seem kind of the same to me. Except I guess educational rounds are usually longer, like they have like a problem G, and Div 2s usually don't have problem G. And like maybe like the last educational round problem is more likely to be like FFT problem or something like that. But yeah. Okay, cool. So all right, so let's attack problem D. This is actually I think easier than B and C, but maybe it's because I have a more of a mathy background. So basically what you have here is you have a squared minus b equals c. And regular Pythagorean triples are a squared plus b squared equals... Oh, they actually don't give you this formula. Okay, so you have to Google a squared plus b squared equals c squared, and that's part of what makes this problem difficult. You know, if that is a source of difficulty. So if you have both of these equations, you can like add them or something, or subtract them, I guess, and you end up getting b squared plus b equals c squared minus c, which you can factor into b times b plus 1 equals c times c minus 1. And if you kind of just look at this, right, maybe you even want to rearrange it into this, if that's helpful. And if you look at this, you basically realize that b plus 1, whoops, I don't know what I'm writing. B plus, wow. Let me write it and then say it out loud. B plus 1 equals c, right? And then you also know that c squared minus b squared equals a squared. So now what you do is you have a squared plus b squared equals b squared plus 2b plus 1, which means b equals a squared minus 1 over 2, c equals a squared plus 1 over 2. And actually, this might look familiar because I think this is like those really kind of standard Pythagorean triples. Like there's a bunch that are like 5, 12, 13 in general, right? Like you can take any value here and you can like make this into a Pythagorean triple if this value is odd, I guess. All right, let me check the chat real quick. Oh, Geothermal wrote a long response to someone's question, but I actually don't see the original. Oh, I see. How do I get good at math forces? I was able to solve A and E. You were able to solve A and E, but nothing else. That's pretty funny. Yeah, I think that Codeforces kind of has like two populations. There's like people who did a lot of math stuff and then started doing competitive programming, and then there's people who started doing programming and competitive programming and then started learning math as they needed it. And they're pretty different in terms of like, and most people are on like some continuum, right? But they're kind of different in terms of which problems are easy versus hard for them. But yeah. Someone said, I don't know that you had an accent. I'm curious where that person is from, right? I think I have a pretty normal, like, East Coast USA accent. Well, sorry, I'm only saying normal because it's what I grew up with. But to me, I don't have an accent, obviously. Okay, so let me quickly write what we were doing. So a squared minus 1 over 2 equals b. A squared plus 1 over 2 equals c. So basically, any odd value of a will let us do this. So we can have a equals 1, 3, 5, etc. And then we just want to make sure that c is less than or equal to n. So let's look at the code. Okay, great. So what I did is I just wrote this thing that tells you whether something is too big. I let a equal to 2i plus 1. So actually a equals 1 doesn't work. So only a equals 3 works. Yeah, someone in the chat pointed that out. A couple people in the chat pointed that out. Awesome. So yeah, so we have I going from 1 through some number, and then a will go through only valid values of a. So if you do this, right, this is basically just a saying whether a squared minus 1 over 2. I didn't do minus 1 just because it'll round down. Plus 1, this is the value of c. We're checking if c is too big. And we're finding the first value so that c is too big, and then we're subtracting 1 because I equals 0 is disallowed, because that would be a equals 1. In general, I think this is a pretty valuable tip. When you're solving these kinds of problems where you have some equation with like a square root or like division or something like that that might give you floating point numbers, it's usually pretty nice to try to work with only integers and then use binary search. Binary search is very fast, so you won't get time limit exceeded because of it in most cases. But there's a lot of precision issues that can come with using square roots. There was a recent @coder problem. That was like counting the number of lattice points in a circle, and it was really hard to get accepted on that if you used square root. And it was much easier if you just used binary search and transformed everything to be only integers, only integer calculations. So someone said they did a linear search. Oh, that's interesting. Okay, yeah. So a linear search just goes up to square root of 10 to the 9th, and you only have 10 to the 4 test cases. So that would end up being like around 10 to the 8th or something. That's pretty funny. Square root happens to work for this problem. Yeah, so in this case, square root does work, but like I'd rather just not have that issue. So I think that it's usually best to try to, like, even if I have to, I actually almost never even use the square root function. I'll usually just binary, like I'll write like a predicate that does like x squared is greater than y, and then I'll use binary search to like compute square roots. Someone said, why do you use long instead of int? That's a great question. I guess I didn't think too hard about the bounds here, so like I figured, oh, a squared might overflow, right? Because we have a going up to 1 billion. But as people pointed out in the chat, you only have a going up to square root of 1 billion, so you could change everything and use 32-bit integers and not have any issues. Great point. And I personally like to I have this pre-written binary search with like a clear invariant or condition. So I very rarely have off by 1 errors when I binary search. Cool. All right, so that was D. Let's move on to E. Someone said that they got time limit exceeded with the square root. I'm guessing you used like Python and the other person used C++. Like 10 to the 8.5 is like pretty borderline. So I think with C++ it would pass. and with... Interesting. Did you use... Yeah, I'm kind of curious about that, but I'm not that curious just because it's like, I don't know. It seems to me like it would be kind of borderline, so it seems pretty easy to make a small implementation change that gives you TLE. So E was actually pretty like implementation heavy problem, I felt. Like okay, so E actually I understand why this is on an educational round. Kind of tying it back to our earlier discussion, because I feel like E is like very, very standard, but it's like you basically have this problem that you transform into like another standard representation and then use like standard algorithms to solve. So that kind of feels like educational in style. Whereas like I feel like a normal div2E would be like more creative. And yeah, E definitely the implementation was a little tricky. I think I had a fairly clean implementation, so I'll try to go through that in a little bit more detail than I go through the normal implementations, in case it's helpful. And if anyone has any, ideas on how to make it even cleaner, that would be cool. Okay. So basically what we're doing here is we have a bunch of, right, like it's pretty natural to express this as like a graph. So you have a bunch of like first courses, I'll say first, second, drink, dessert. Then you have some second courses, and then you have some drinks, and then you have some desserts. And basically what they're saying is there are some, like, you want to pick a first course, and then you want to add like a second course, and then you want to add a drink, and then you want to add a dessert. So you can kind of think about this as a graph, right? Like let's say we pick the first course, the second course, the second drink, and the first dessert. That's like this path through the graph, and we take the sum of the costs of each node. And you can, and this is pretty natural also because they give you pairs of first courses and second courses and drinks and desserts. So this layer representation is like very, very natural. Oh, Pulgster subscribed. Thank you so much. That's awesome. So let's see. Oh, and thanks for the follows, everyone. Also very appreciated. So at first you kind of think, well, you can just approach this as a graph, right? Like these constraints are a little big, but they're not that big. Like the total number of nodes in the graph is 600,000, and the total number of these edges is also 600,000. But then you realize that when they're giving you the things, they're not giving you the things that go well. They're giving you the things that don't go well. So the total number of edges could actually be n squared, which is a lot higher. But basically, like, you imagine you have this graph, and almost everything is connected between layers, and you want to find like the best path through. So the way that I approached this is if you look at a single layer and you want to figure out the cost for like this node, for example, I'll use another color. If you want to figure out the cost for this node, and you have a couple bad edges, like let's say those are your bad edges, then all the valid candidates are the things in between the bad edges. So these have like, and I drew this as the last layer, but it doesn't actually matter. So basically the idea here is if you look at these intervals and you have some kind of interval query data structure, you have at most the number of intervals is the number of bad edges, or the number of bad edges plus 1. So this ends up giving us an O of, I'll use capital N to be the sum of n, and capital M to be the sum of m. This gives us an O of n times m times, actually I'll write it a little bit more explicitly. This ends up giving us, like, to go from layer I to layer I plus 1, it takes something like O of ni log ni plus ni plus 1 times mi. So for each node in the new layer, we have to do this many different interval queries to get the ranges in the previous layer. And then we have to do some pre-computation in the previous layer here to be able to do those range queries efficiently. So the data structure that we're using here is called a sparse table, which allows you to construct, if you have an array, you can construct a sparse table in n log n, and then that allows you to query any range in O of 1, which is where we get this runtime. So this is the runtime, then you sum that over I, and it ends up like multiplying it by 3 or 4 or something. Oh, you know what? Yeah, so actually, I wrote this wrong. Yeah, thank you so much. So, yeah, so this ends up being like, a plus sign. The reason for this is for any given element, you have the number of bad edges going to it as the number of queries, and the total number of bad edges is m sub I. So yeah, so as pointed out in the chat, this is the right approach, but I wrote the runtime wrong, and the runtime that I wrote would have TLE'd, but this should be fine. Someone said, can you use segment tree instead of sparse table? Yeah, you can also use a segment tree. I think that would be fine. What that would do is this mi would be multiplied by a log of ni or something. Yeah, so the queries here would be log time. And then, and then I also sorted these bad edges, so that adds like another like mi times log mi factor, right? But basically this is like, whatever this kind of sum of the size of the input is, it's that times log of that. So it's a bit of a complex problem, but it's fairly straightforward. So let me go over my implementation, which I think is pretty good. But it's a bit long, but this problem was inherently a bit long as well. So I tried to be pretty systematic about this. Cool. So first what I did is, just to avoid like having to copy paste code or messing up my indices, I just kind of set z equal to 4. So I could do everything using loops. Excuse me. So first we just read the input. And then for when we're reading the bad edges, I immediately wanted to categorize them by the second endpoint. So I have a vector of integers for the bad edges. So what this does is, for the ith layer, I guess I actually, yeah, so I did this in such a way that the first one is just empty. It doesn't really matter. But basically what you do is for the point in the second phase of the two phases you're considering, you look at all the previous things that are not allowed. So now you have your vector of what's the minimum cost to get to this thing. And then for each phase, right, this is a bit long, but essentially what we're doing is to get from a phase to the next phase, what you do is you first create this sparse table on the items from the previous phase, so you can do your range queries. You put in the bad edges into like a single vector. Then you add -1 and the very last thing, so that you can kind of, each interval is represented as between two consecutive bad edges. And then you just consider each interval, and then you take the min of all of them, and then you make sure that you add the cost from like the node that we're going to. And then we just loop over everything in the last phase and get the min. Okay, let me see the chat. Okay, Neil says, for E, I sorted DP values from the previous course. Then for each next course option, I looped up the sorted list until I found one that wasn't bad for it. Ah, I see. Okay, so you sorted the DP values. Okay, so you had like a pair or like an index or something, right, with the index and the value, and then you found the best one that was allowed. Okay, that makes sense. That sounds similar to someone else's priority queue solution. I guess let's look at Neil's code briefly. Nice. Easy to find. Okay, yeah, so C here is the number of phases. Okay. So we have a vector of ints. Wait. Okay, yeah, I see. So we have the vector. Okay, that sounds good. Okay, yeah, so here this is just the indices, so you find the best index from the previous phase that's allowed. And that's what this is doing. Okay, that's pretty nice. Okay, so cool. So that actually kind of wraps it up for the problems that I actually was able to solve. Let me go over my approach to G a bit. Though I wasn't able to finish solving it. Also, if anyone has any like thoughts about the contest or anything, let me know. And I guess always, as always, don't forget to follow. Check out my YouTube and Discord. You can check out my future content that way. Okay, cool. So yeah, let's think about G a little bit. I'll kind of just highlight a few of the observations that I made. And then those don't actually completely lead to solution, but they're, I think, helpful. So there's a couple interesting constraints in the problem statement, which at first I wasn't sure like why they were even helpful. But so if we look at the constraint about palindromes of odd length, you'll notice that if you have any palindrome of odd length, then that means that you have a palindrome of length 3. Because if you take any palindrome of odd length, right, it looks something like this, and then the middle of it is a palindrome of length 3. So if you want to avoid odd length palindromes, you don't need to like think about all possible lengths, you just need to avoid length 3. Because if you have length 3, you also have an odd length palindrome. So this is kind of like an exactly equivalent condition that's much simpler to think about. Because a palindrome of length 3 just means you have SI equals SI plus 2 for some I. Cool. So that's kind of the first constraint that you have to think about to optimize a little. The next observation is if each letter has at least n over 3 copies that we can use, one thing we can do is count all strings without thinking about whether the letters are within our, I guess, like letter bank capacity or not. And then we can try to subtract the strings that use too much of a letter. And the number of letters that you'll use too much of is at most 2, and at least 0. So I think that you can solve this kind of using a bit of an inclusion-exclusion style approach, where you can count all the strings, and then you can subtract strings that have too many A's, B's, etc. And then I think you might want to add back the strings that have like too many A's and B's, too many A's and C's, etc. And the thing that's kind of nice about this is, right, you know there are going to be at most 2 things for your inclusion-exclusion. The reason for that being that you have greater than n over 3 of each letter available. So if you hypothetically had too many A's, B's, and C's, that would mean that the number of A's is greater than n over 3, and same for the number of B's and C's, and that doesn't make any sense, because then the total length of the string would be more than n. So this is kind of the approach that I took. I wrote like a DP to try to solve this, that I think its time limit exceeded, and is also like not quite right. But basically the idea is I tried to count how many strings you could get of a given length that had a certain number of A's and a certain number of B's, because you can kind of treat all of the letters as equivalent until the very end when you're checking them versus their counts. So then I did that, and then what I tried to do is I tried to add up like the total number of strings, and then I tried to subtract the strings where you have like too many A's and too many B's, or too many A's and too many C's, and things like that. Definitely ran out of time while implementing this, but I think it can be done. The only problem is the way that I implemented it has a pretty bad complexity. It's n cubed times like some not very nice constant, which is definitely a bit too high for this problem. At least I tried running it locally and it wasn't very fast. But yeah, in terms of exposition, that basically wraps it up for this round. I might try to finish implementing G later, because I'm definitely pretty interested in the problem. F, I basically didn't really look at it. I just saw that G seemed like it had more solves, so I figured I would attack G. And also looking at G, I kind of felt like I had an idea on it. But yeah, I guess let's look at the standings. I'm kind of curious how people did on this contest in general. Okay, nice. So 6 people actually solved everything. It seems like F was very tricky. People got a lot of wrong answers on it. Yeah, so n cubed, I think if it were just n cubed, that would be okay, because it's like 400. Yeah, I think n cubed is like kind of borderline. But I think it would be fine. But then you have like a pretty bad constant factor on it from the way that I was implementing it. So I think that can definitely be improved. But yeah, seems like a lot more people were able to do F. Or sorry, were able to do G compared to F. Oh, someone said Muffin Head got first last competition too. Oh, that's awesome. Generic placeholder name F. I did a brute force with cache and all the states just collapsed together. Oh, okay. So did you do something like like a BFS or something like that. Also, generic placeholder name. What's your Codeforces handle? I guess it's one of a very small number of handles. Let's see who solved F. Wow, I wonder if these are alts or if these are oh, maybe these are people who solved it after the contest? No, this is all in contest. Okay. I wonder if this is an alt or oh, generic placeholder name is generic placeholder name on Codeforces. Okay, very cool. Except you have an extra C in your Twitch name. Is that because it was unavailable? Okay, cool. So yeah, that basically wraps up my solutions to the problems in this contest, A through E. So I guess I'll just close with this will be up on my YouTube later if you want to rewatch it or or figure something out there. And feel free to join my Discord and kind of connect to the other viewers and me. um, and as always, be sure to follow and subscribe if you can, just to stay in touch with my future streams. But yeah, definitely a pretty cool contest. B was weirdly hard for me, but I guess it was simpler once you really broke it down. And I think C was a little bit of a not a great problem to put on this kind of contest because I think it's kind of guessable. Like for C, I kind of guessed that something was good enough, but I didn't actually prove it. So problems like that are always a little bit weird because you kind of really reward the people who just submit something hoping it's right. Which in this case, I was one of those people. But yeah, pretty fun contest, and thanks everybody for joining the stream. It was definitely a lot of fun for me, as always. So, bye everyone.